Part 2 of your test is the calculator portion. So our first part here, you are given a table. We have two x values, 1 and -2, and then we are given f of those values, f prime of those values, g of those values, and g prime of those values. So we're going to be using the rules for derivatives and this chart. Okay, first up, the derivative of f of x plus g of x. So that's just going to be f prime at -2 plus g prime at -2. So we use the chart at -2. F prime is -5. G prime is 7. So we get 2. F of g, that's going to be f prime g of, in this case, -2 times g prime of -2. F prime g of -2 is 1. G prime of -2 is 7. F prime of 1 is 1. No, f prime of 1, is 3. 3 times 7 is 21. G of f is going to be g prime f of -2 times f prime -2, so just applying the chain rule. G prime f of -2 is -2. So g prime of -2 is 7. F prime of -2 is -5. So this is -35. Okay, f times g. So this is going to be f prime of 1 times g of 1 plus g prime of 1, f of 1. F prime of 1 is 3, g of 1 is -2, g prime of 1 is -1, f of 1 is 1. So we have -6 minus 1, which is -7. Next we have a quotient. So this is going to be f prime of -2, g of -2, minus g prime of -2, f of -2, all over g of -2 squared. F prime of -2 is -5, g of -2 is 1, minus g prime of -2 is 7, f of -2 is -2, g of -2 is still 1, so this will be a -5 plus 14 over 1, which is 9. Okay, last we have the reciprocal, which is going to be negative g prime at -2 over g of -2 squared. So we're going to have a negative g prime of -2 is 7. G of -2 is 1 squared, so this is -7. Okay, so we have this piecewise here. F of x equals ax plus b when x is less than 1, and x squared minus ax when x is greater than 1, where a and b are constants. So we're going to find the constants a and b so that this is continuous and differentiable. In order for it to be continuous, we need this at 1 to be the same as this at 1. And I can use limits to help me out with that. So as x goes to 1, ax plus b is going to be a plus b. As this one goes to 1, we're going to have 1 minus a. So for it to be continuous, a plus b needs to equal 1 minus a, or 2a plus b needs to equal 1. Okay, so we need more information to find out what any a and b satisfies this will make it continuous. To make it differentiable, I need their derivatives at 1 to equal. Well, if I take the derivative of ax plus b, that's just going to be a. The derivative of x squared minus ax is going to be 2x minus a. Okay, so I want those two to be equal when x is equal to 1. So when x is equal to 1, a is just going to be a. 2x minus a is going to be 2 minus a. So 2a equals 2. So my a is 1. Then I need to go back to here to figure out my b. So 2 times 1 plus b equals 1. So b is going to be negative 1. So a is 1, b is negative 1, and the graph will confirm it. So if I fill in those constants that we just got, my new function is going to be ax, which is 1x, plus b, which is negative 1. And then x squared minus ax, which is just 1 again, when x is greater than or equal to 1. Okay, so you have a calculator if you need help with the graphs, but x minus 1 is just a y-intercept of 1 and a line with a slope of 1. When we plug 1 in here, we get 0, which is good news. That makes it continuous. And then if I plug in 2, we'd have 4 minus 2, which would be 2. And then it's just going to continue up like that. Okay, the table below defines f of x on the interval 0 to 8, approximate the derivative at x equals 6. So x equals 6, we're going to be looking around it. Okay, derivative is the slope, so if I find the slope nearby, then we're good. So I'm going to do f of 8 minus f of 4 over 8 minus 4. Then from the chart, that's 0 minus 3 over 4, or negative 3/4. This is called a difference quotient. Okay. This next one is from an actual AP problem. So on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this equation here, where t is measured in hours from 0 to 8. Find the average rate of change from 0 to 5. So that's going to be g of 5 minus g of 0 over 5 minus 0. So what I'm going to do here in the calculator, get rid of anything you have. In your y equals, I want you to put this equation. So 90 plus 45 cosine x squared over 18. Okay, so now I can evaluate. So here I'm going to do fraction. On the top, I want y1 evaluated at 5 minus y1 evaluated at 0 over 5 minus 0. Okay, and then we're going to do this to 3 decimal places. So negative 7.372. This is in, the rate is in tons per hour. Okay, so this is tons per hour. This is hours, so this is tons per hour per hour. Okay, find g prime of 5. So in your calculator, you're going to do alpha of 2, the numerical derivative of y1, evaluated at 5. So that is negative 24.587 or 588. Same units, tons per hour per hour. Then you're asked to interpret your answer in the context of the problem. For our interpretation, g of t is the rate at which the gravel is arriving. So this means that the rate at which the gravel is arriving is decreasing by 24.588 tons per hour at time equals 5. Okay, this next graph, we're just looking at differentiability. So it says state where the function is not differentiable and why. So we've got a lot of locations where it's not differentiable. This one and this one, so x equals negative 2 and x equals 4 are discontinuous. So it is not differentiable at 0, 2, and 6. There's a sharp shift or a corner, so it is not differentiable. Okay, where does it have a negative tangent line? Well, that's going to be anywhere where the graph is decreasing. So that's going to be from negative 2 to 0, and then from 2 to 4. Where does it have a positive slope? Well, anywhere where it's increasing. So from 0 to 2, and from 4 to 6. Sorry. And then where it has to have a horizontal tangent line, that's going to be here and here. And remember, there's a restriction here. So the last part there is going to be from negative 4 to negative 2, and again from 6 until 8. And that is the calculator portion of your test.